When crossing hills, it's important to have plenty of water. This is the story about how the Grand Junction Canal solved this problem on the Tring summit. When the Tring summit was cut through the chalk of the Chiltern Hills, the section wasn't lined in clay like normally done to hold water. This is because the water table in the area was higher than the canal, and the water leaked through the chalk into the canal, filling it up. Extra water was brought in from chalk streams near Wendover, and this originally was going to be a feeder arm, but because it wasn't that much harder, it was built to navigational sizes. Each time a boat crosses the summit, nearly 180,000 gallons, that's 670,000 litres of water is used, and as the canal got busier, it was obvious there wasn't enough supply. In 1802, the Wilstone Reservoir was created and fed the White House's pumping station nearby on the Wendover arm. It is the largest of the four reservoirs, covering 119 acres, that's 48 hectares, and is up to 18 feet, that's 5.5 metres deep. Over the following years it was enlarged, and it now has the capacity for 1 million megalitres of water. That's the equivalent of 450 Olympic-sized swimming pools. There's not much left of the White House's pumping station now, but it originally housed a Newcomen beam engine. There the reservoirs were built, including the Marsworth Reservoir, completed in 1806, Tringford Reservoir, completed in 1814, and Starup's End, completed in 1815. With these new reservoirs, a new pumping station was created at Tringford. However, the White House's pumping station did continue to operate until around 1835. The building you see today has had many changes. Originally it housed a Boulton & Watt beam engine which managed to move 80 locs worth of water per day. Later all of the Tring reservoirs were connected by a system of tunnels to enable all the pumping to be centralised on Tringford. A second-hand steam pump named the York was installed to handle the increased load, and this engine remained in operation until 1911. The two diesels, one a 50 horsepower and another two-cylinder 100 brake horsepower, were dispatched from the factory in April 1912. The engines were an air blast injection type and ran at 250 RPM. They were used to drive dynamos to provide electrical power at 220 volts DC. Both engines remained in use until the early 1960s. This model gives you an idea of how the beam engines used to operate. A long shaft with valves on would be sunk into the well that was fed by the reservoir, and on each upward stroke the valves would close and lift the water. On this 1911 drawing you can see the Boulton & Watt beam engine and the two other wells powered by the diesels. If you notice, all the reservoirs are at different levels. This is to make best use of the water that they have available. Some of the lower lying reservoirs can pick up water from the surrounding land. The higher reservoirs collect water from springs and from the Tring arm, which by this time was already blocked off due to leakage. There used to be a pump on the Marsworth Reservoir to take it up to the Tring level. However, that was disbanded in 1818, only 12 years after it was built. Heading down the steps of the number 1 pump well takes you 20 foot below the Tring summit water level. This pump, which is just above the weir level of the Tringford Reservoir, used to be connected to the 50 horsepower Merlise diesel engine. The DC motor was replaced with an AC motor in 1955. Apart from some regular maintenance, this is the original pump that was installed in 1912. Number 2 pump is situated 16 foot below the weir level of the Starrop's End Reservoir. It can pump under pressure from Starrop's End, or it can pull from the Wilston Reservoir, where the weir level is situated only a few feet below the pump. In 1927, there was further changes. The original Boulton and Watt steam engine was scrapped, and the building remodelled with chimney and upper storeys removed to what we see today. To remove the nearly 7-ton beam, an end gable wall was removed. At this time, newer 11 kV AC main supply was installed, and new AC electric pumps installed in number 3 well. These 2 pumps, installed in 1927, are Rees Roturbo twin vertical access pumps with Lancashire dynamo motors. Each one is 55 horsepower or 41 kilowatts at 1040 RPM. With both pumps running, the discharge is 3¼ locks per hour, and they pump 17 metres, 55.5 feet, either from Wilston or from the Starrop's Reservoir. Both pumps are still using their original bushings, which was made out of a particular tropical hardwood called lignum vitae. This is a common material in these applications, but it goes to show that even after over 100 years, they've picked the right material for the job. This is one of the headings to the reservoirs, possibly to Wilston. It was hand dug through the chalk to provide the flow of water to the pumps. This is the main power distribution board with switches off to each of the 3 pump wells. This was all filmed during a 2017 Heritage Open Day, which was pre-Canal and River Trust takeover. You can see a lot of the old signage, and they had a museum of sorts. The old ironwork and templates were stored on shelves around the building. The water control around the Tring summit is quite complicated, and there's a lot of different sources of water. Over the years, extra sources have been brought online. Here is a diagram of all the sources of water currently feeding the Tring summit and the area. As it can be seen, some of these reservoirs can feed directly into, for example, the Aylesbury Arm without the need of pumps. Added onto the sources of water are two deep wells, one at Cowroast and one at North Church. And while it's caused some problems in the past, the local Tring sewage works also feeds the Marsworth Reservoir, making sure that all of the sources of water are captured for later use. I hope you've enjoyed this video, and if you have done so, please hit the like button so you see more of this sort of stuff in the future. Another interesting quick factoid is that the balls on top of these columns are actually from the speed regulator of the Bolton and Watt beam engine. What was your most interesting fact, and have you got any further questions? Please comment below, and keep an eye out for future exciting videos coming soon.